Here we have the power series of n plus 1 factorial times x to the n, and we want to find the interval convergence. And so before we do that, recall that we have 0 factorial, then it's defined as 1, and 0 with exponent or with the power of 0 is also equal to 1. And so for this power series right here, if we let x be 0, then in the place of x, we have 0. So we have 0 right here. Since we let x be 1, be 0. When n starts at 0, so when n is 0, we get 0 plus 1 is 1 factorial, and then n is 0, so we get 0 to the 0. When n is 1, we get 2 here and 1 here, so 2 and 1. When n is 2, we get 3 here and we get 2 here, so we get 3 and then we get 2 there. And then when n is 3, then we get 4 factorial, and then we get 3 to the 3, and so on. 1 factorial is just 1. 0 to the 0 is defined as 1. So we get 1 time, and then this is 0. And then 2 factorial times 0 to the first is just 0. So we get 0 here, we get 0, we get 0. So when x is 0, then this series is just going to be 1 plus zeros. So we get 1. And so this power series right here converges to 1. So this power series right here converges to 1 when x is 0. And now what about if x is not 0? Then if x is not 0, then we need to do use the ratio test and do the u sub n, find the limit of the ratio u sub n plus 1 and dividing by u sub n. And then set this limit right here to be less than 1. And then we can find the interval convergence. So here we let u sub n be n plus 1, so u sub n is this. U sub n will be n plus 1 factorial times x to the n. And then u sub n plus 1, in the place of n, we put n plus 1. So we put n plus 1 here, and then we put n plus 1 here. This becomes n plus 2 factorial, and then x to the n plus 1 is the same as x to the n times x to the first. And so now we get n plus 2 factorial times x to the n, and then x to the first is just x. And so u sub n is n plus 1 factorial times x to the n. U sub n plus 1 is n plus 2 factorial times x to the n times x. And so now we need to do the ratio to do u sub n plus 1 dividing by u sub n. U sub n plus 1 dividing by u sub n, then it would be this part dividing by this part. So we have n plus 2 factorial x to the n times x dividing by n plus 1 factorial times x to the n. But the x to the n cancels out. So what's left is n plus 2 factorial times x dividing by n plus 1 factorial. And then we can rewrite this as n plus 2 factorial dividing by n plus 1 factorial, and then times the absolute value of x. And then now let's simplify this part, the n plus 2 factorial dividing by n plus 1 factorial. N plus 2 factorial, it means n plus 2 times n plus 1 times n minus 1 and then all the way down to 3, 2, 1. And then n plus 1 is just n plus 1 times n times n minus 1, all the way down to 3, 2, 1. And then we can see that this part right here will cancel out with this part. And what's left is just n plus 2. So n plus 2 factorial dividing by n plus 1 factorial is n plus 2. So this part is just going to be n plus 2. And so now we need to do the limit of u sub n plus 1 divided by u sub n. So the limit and then u sub n plus 1 dividing by u sub n is this part times the absolute value of x, but n plus 2 factorial dividing by n plus 1 factorial is n plus 2. So we have n plus 2. And then we have a limit, and then we can rewrite this as this. So limit of a product is just product of limits. The limit of n plus 2 will be infinity, because as n approaches infinity, n plus 2 approaches infinity. The limit here is with respect to n, so there's no n here. So you can think of it as a constant. And so we get just absolute value of x. And then infinity times the absolute value of x, we get infinity, which is greater than 1. And so this limit right here of u sub n plus u sub n plus 1 divided by u sub n will always be greater than 1, except for x equal to 0, as we have shown earlier. And therefore, this power series right here diverges for any x that's not 0. Meaning if we pick any number that is not 0 and put it in the place of x, then this series diverges. And so the series, one more time, as we have shown earlier, converges to 1 when x is equal to 0. So if x is not 0, then the power series diverges. But if x is 0, the power series converges to 1. And so since the only value that for x that would make this series converges is just the x equal to 0. And so for interval convergence is no longer an interval, since we just have the single number 0. And so we would write it like this, 0. And so that's how we find the interval convergence for this particular series, this power series of n plus 1 factorial times x to the n.